Hey everybody! So I thought we'd do a little video to kind of go over the different engineering challenges, and I use the word engineering in quotes because I am far from an engineer. But I thought we'd kind of talk about some of the engineering challenges in building a hidden room safely. And so to kind of give you an idea of some of my requirements, I needed the door to swing out. If you go into my bathroom, it would just be in the way if it swung in. There's a shower to the right, there's a sink to the left, and it just would not be good for that door to swing out or to swing in. So I needed that to be to come out. The next thing that was really important to me is that the door needed to be functional. Like it needed to. I don't have a ton of space in my shop, and so I wanted to be able to hang something on it or do something with it to where it's not just wasted space with a whole bunch of engineering. The third thing that was pretty important to me is that I wanted the door to open on its own. Like it wouldn't be enough for me if you pushed a button and the door went click and then you had to walk over it and just open the door manually. I wanted the door to fully open on its own. The next thing that was really important to me is that whatever I put on the door, bathroom doors are 24 inches, something like that. So I didn't want it to be a really narrow thing that basically looked like, oh, well, that's a door. And so I wanted it to be wider than the door, even though I don't have a ton of room on that wall. I wanted it to be wider. And then the last thing was I didn't want it to be trimmed out. I didn't want to try to hide anything with trim, because the minute you spot trim around something like this, if it's a pegboard, it's obvious something else is going on there. So that was pretty important to me. To make all that happen, there were some challenges. And first of all, in terms of priority, just like the crazy Russian hacker, safety was my number one priority. And so I wanted to make sure that this was done safely. So what were some of the things that I did to make that happen? Well, the first thing and the most obvious thing is you never want someone to get trapped in the bathroom. And so that big magnet I have at the top of the bathroom, like when the door swings, there's a magnet up here, and it's like maybe a 600-pound, 1,200-pound magnet. I don't know. I don't have the power set all the way on it, so you could ram it open if you really needed to. But basically, the way this magnet works, and they have both styles. They have what they call fail secure, and fail secure means that basically you put electricity to it to open it. And when the electricity goes off, that door is going to stay locked. So if you have a bank or something like that, you don't want cutting the power to immediately make all your doors open. So what I did is I got the opposite style. I had fail open, which means that in order to open the door, whether the relay triggers and basically releases the electromagnet, and that's how the door opens. And so from my perspective, that pretty much took care of the idea of getting trapped in the bathroom. Now, you'll see if you've ever seen some buildings, and I'll try to put up a picture, but a lot of them have this push to exit button. And I originally hooked one of those up, and you'll see in the video, but basically what I figured out was that button triggers a relay or some kind of contact inside of the power supply. In fact, I realized I had another power supply from another project sitting over here. And so basically the way these things work is they do have a little thing that you can connect a button between push and ground. And when you push that button, you can clearly hear a contact trigger in here. And the problem was it didn't work every time. And it even has a delay here that you can decide how long that's going to hold it open or closed. And so I didn't trust that. I didn't trust that this Chinesium little power supply thing, that this relay would never go bad. So what I decided to do was, in order to disconnect the lock inside of the bathroom, there's an actual physical switch that cuts the magnetic that cuts the power to the magnet directly. So basically, it doesn't matter, power on, power off, battery backup, anything. If you're inside the bathroom and you flip the switch, you are completely cutting power to the bathroom, which means that you cannot or not to the bathroom lock, which means that you can't get triggered on that side. Now, the other side was a little bit simpler. So, I have friends who are idiots, and, I just was envisioning that you're sitting there on the toilet and your friends decide to go over there and hit the breaker to trigger the bathroom door while you're sitting there. And so, that's solved with a really easy slide lock. So basically on the inside, if you want security, so security to not get locked in is the full disconnection of the power supply to the magnet, and the security to prevent somebody from breaking in is a physical slide lock that can only be actuated from the inside. So that takes care of those two problems. There's also a sign that basically says if the power goes out, a glow-in-the-dark sign saying you're not locked in. I don't think that was in the video, but it's there. So the next thing that was really important to me, or that was kind of a challenge, was the fact that this thing had to slide. And I want to demonstrate this. So picture this as the door. Basically, if it was like this, if it was dead even, you would be able to see cracks and you'd be able to see all kinds of things over here, and it would be really obvious that something was there. So in order to hide the doorway, this has to slide this way. And when that happens, I'm going to try to rotate it at an angle, no matter what you do, you're going to hit. So like in this case, I'm an inch past and the door doesn't open. It's going to hit the wall. And so basically there's two things you can do. If I stand this up, there's two things you can do. You can either have this on some kind of arm where this, as the door opens, this kind of comes out and moves over like this, or you can have it on some kind of track system, which is what I did, to where as the door opens, this actually slides over. And now, I didn't expect that to be as big of a problem as it was. Part of the issue, I'll bring back my demonstration real quick. Part of the issue is if you look at somebody who has a barn door track, the barn door track is way longer than the doorway, and it sits on the outside. So if you have, let's just give some simple math. If you have a 24-inch door, this is a 12-inch door. In order to have a 12-inch door, you would have a little bit more than 24 inches of track on the outside for this thing to be able to slide all the way to one side or all the way to the other side. You need basically twice the width of the door plus an inch or two to make that work. So that wasn't going to work. If I had a big track on the outside of my wall, it would be really obvious. So the next challenge was that this track had to be hidden. And not only did it have to be hidden, but it had to be confined to the width of the door, not the width of the pegboard. Because obviously if something's sliding out, I can't just let it slide in free air when there's no door behind it. So the door is roughly 24 inches and this thing is wider, and so it needs to be able to slide wider. So I tried a few different things. My first prototype actually involved this and eye hooks, and it worked amazingly well. It slid really well. Everything worked really well. I was able to put one of these bars on the top and one on the bottom, and everything slid really well until I got a lot of weight on it. And then two things were at play. One is because of the fact that this thing, so this is my bar for my door, but the pegboard inherently has to slide out past the end of the door. It's always going to be off balance. And so you basically need to counterbalance this thing, and just the more these things tweak, like the less that they want to go anywhere. And so that didn't work. And then I decided to try, well, maybe I could do some kind of roller system where I have one on the top and one on the bottom, and these would roll. And I thought that would work pretty well, but same thing, as this board gets out, once you get out this way, it immediately wants to go this way, which means that first of all, you have to have pulleys on the top and the bottom. I think I have another pulley here. You have to have pulleys on the top and the bottom, and as you do, they want to go like this. The pulley, no matter what you do to connect them, they're going to want to go to the side, and they're just not as efficient in dragging that way when they're on their side. So that's a problem. And so the last thing I figured out on that front was that having a bar at the top and the bottom actually made it worse because of the whole torsion thing. So what I decided to do to solve that, it was two things. One is for the top, what I did was I used a bar, like a piece of aluminum stock, and basically the idea of that is that there's just a lot less surface area for the pulley to have to deal with, and so I'm able to get it to get way tight in the groove, and there's just a lot less resistance. And then instead of trying to, all my attempts in the beginning were trying to force this thing to go in a certain direction. Instead what I did, and this isn't an exact wheel, but instead what I did, on the bottom I added 2 drag wheels that just roll along the door. And so instead of trying to force this thing to be parallel all the time, this wheel, which I didn't get ones that rotate, but this wheel that can only go, left to right, is able to sort of drag and follow whatever path this thing wants to go. And so that was the trick. That was the trick to getting this really heavy door to slide every time I open the door. Now, so how does it actually work? So you have this aluminum and you have this door, and you're going to get the top view here. And so we're all connected here, and this is spaced out a little bit. And again, no matter how far you space this out, you have to deal with the wall on the other side. So what happens is there's actually a little bumper on this side. And what the bumper does is the bumper is what the pegboard crashes into the bumper as the door opens. And because the door is on pulleys, it just keeps, so let me demonstrate it this way. The door hits the bumper as it opens, and it just slides on its own because it can roll free on those top pulleys, and it has those bottom guide wheels to allow it to move without a whole lot of resistance, considering how heavy it is. So speaking of weight, the next thing you have to deal with is the fact that you are not going to hang all of that hardware on your pre-hung hollow core door from Home Depot. And my bathroom was already built when I bought the house. It was missing some parts and stuff like that, and it was just an open frame, but the shower was already there, and it's a tile shower and all that stuff. So I knew that I needed a solid core door, and so what I decided to do was to go on Craigslist, and I found one for $25, and they just said it was a big solid core door. Great. So I show up late at night, and the thing was unbelievably big and heavy. It was 8 foot tall and 40 inches wide. I mean, that is a massive door. In fact, for those of you guys who are on the metric system, that is 2.438 billion nanometers by 1.06 billion nanometers wide. Like, it's huge. It was a huge door. And so I barely got it into the van by myself and got it home, and I was able to cut it down to about the right size that would fit. But then I had to deal with the fact that basically when you come in the bathroom, if this is the doorway, you come over here, there's a shower, and this is a tile shower wall. And I was really concerned that if I start beating on this wall, and I start doing a lot to reinforce this wall, that I was gonna mess up the tile inside this bathroom. Like, you're just not gonna take a 5-pound sledge and beat stuff into submission. So basically what I did was I left the existing vertical alone, and I made my own frame for this thing out of 2x6s. And so I mortised the hinges in there and basically just had to make my own frame to where, and then this was already a double over here. So I was able to basically go in through 3 2x worth of wood and hang that extremely heavy door on that. And then on the front of that door have 3/4 inch bolts or 1/2 inch bolts and pegboards and stuff hung on it, all resting on these 3, 4, 4.5 inch hinges on this side. And so just a ton of weight had to be dealt with. So one thing I was not expecting to be a problem until I tried to research it was the fact that, as I said earlier, I didn't want, when that magnet released, I didn't want it to just come here and just pop the door a little bit and then I walk over and I open the door. I wanted the door to open on its own. And that was a pretty tall order. If you start Googling around for, self-opening hinges, I mean, there are a million products to make sure that your pull gate closes so no kid falls in it. And there's all kinds of door closers on the market, but when it comes to door openers, like, they're just not really out there. I mean, there's a few, but they're these giant powered commercial monstrosities and things like that. And there's a few self-opening hinges that are sort of made for gates and stuff like that, but they were expensive and they didn't have a lot of power when I looked at the reviews and all that stuff. And so basically what I wanted to do is I wanted a controllable opening. So I wanted the door to open, but the last thing I wanted was everything on my pegboard to wind up on the floor as this door just whipped open. So I needed a way to control it. So I went down to Lowe's, and I eventually found these at a yard sale, which was great because I got 4 of them for $1 a piece. And I found these type of door. This is a door closer. You'll notice door closer. Well, just by chance, I decided to buy it and see what I could do with it. And yeah, I mean, by default, if you screw this thing on there, it kind of this attaches to the door and is made to kind of push. Well, by default, if you crank the ever-living crap out of this thing, and basically you almost do it like a garage door spring, you mount this thing on there, and then you use, there's like a little nubbin tool. I guess I might have that around here. There's this, so you have this thing mounted to the door with nothing on it. And then you can screw, let's see if I can get you a good angle. You can screw this thing on there, and basically what I figured out is if you back this up and then you get one hand on it and you put the next handle on it, and then you keep cranking around, taking one hand off and putting the next one on, you can actually turn this thing into a door closer or into a door opener. And so it has some pretension, and I've actually had that part of the system working for the better part of 6 months. Like it works beautifully. And basically, the more times you crank this sucker around, the more times that the faster the door will open. And so, in fact, before I painted the door, like, this thing actually will just wear a groove in the door when it pushes on it. So I wound up putting a piece of aluminum where each one of these things contacts, so it has a nice smooth metal surface to drag on. But that's, there's some force in this thing, but basically it can take that super heavy door, 2 of them can take that super heavy door and just gently open it up. And it's a beautiful thing. Like, this is a pretty nifty little trick. And when all was said and done, this is the end result. Thanks for watching.